Hello, and thank you for tuning into our presentation. In this work, we tackle the problem of aerodynamic parameter identification in fixed-wing UAVs. These parameters define the overall flight characteristics of the aircraft, but are hard to come by. Wind tunnel measurements are often an unbalanced investment in a UAV project budget, so we propose an identification methodology which depends only on flight data from a typical INS, a thrust model, and the control inputs. We define our problem as the parameter estimation of a nonlinear model which is linear in the parameters. Simple approaches based on linear least squares are not adequate because they cannot account for noise and errors in the explanatory variables. However, in real-life cases, such errors exist and lead to biased parameters. GTLS is able to account for noise and bad scaling in the explanatory variables, survive intervals of insufficient system excitation, and be implemented online using recursive SVD updates. The eigenvalues of the scale data matrix D* are reflective of the current status of the identification procedure. By specifying a required time-variance signal-to-noise ratio, we can compare the instantaneous eigenvalues against it and deduce the status of the identification. If all the eigenvalues rise above this excitation threshold, then the identification is complete. The smallest eigenvalue always corresponds to the modeling noise and should not be taken into account. We have also endowed our methodology with a variable forgetting factor. Our VFF scheme is able to maintain all excitation information, making it robust against long intervals without excitation, and in case of model change, the VFF decreases, essentially resetting the identification. In this simulation example, the aerodynamic parameters of a fixed-wing UAV have been identified. At some point, the aircraft is led to an aerodynamic stall, resulting in a change in the lift model. Our parameter identification scheme detects the model mismatch and reduces the VFF value. Throughout the short stall, old and inconsistent data are forgotten. As soon as the aircraft flies nominally again, VFF rises and the parameters are identified anew. We have tested our algorithm on real data, captured from our Unitrap UAV. Data points were fed to our algorithm sequentially, resulting in convergent parameter estimates. Most of the required excitation data points had already occurred before the scheduled excitation maneuvers. However, by observing the trajectory of the eigenvalues, we notice how that last bit of purposeful excitation was indeed necessary for the identification procedure to complete. Thanks for watching.